In the past year, we've suddenly had an explosion of applications come to our smartphones that take advantage of the sensors that are packed in them. The iPhone has about 10 different sensors, and these applications take advantage of the data that can be gathered by those sensors, upload them to services, and then those services turn around and use that data. They provide a service to the user, and then they sell the data on the other side to fund the service. And I'm going to bring up 4 different companies or 4 different people to talk about how they're each using this abundant data in their own way. Now, first, I'd like to welcome up the community geographer of Waze and the chairperson of Palatial, Diane Eisnor.
Thank you, Brady. So we can just start the video. I've been working with crowdsourcing of map information for quite a few years. Oh, that went by very, very quickly. But what you would have seen was information from crowdsourcing everything from Twitter feeds to standard map information. And what we're doing is we're taking a lot of these ideas where crowdsourcing meets real-time information, and we're creating Waze. Waze is crowdsourced navigation and real-time traffic information. Just like any other navigation application, it's going to give you a route, voice turn by turn. It's free. But the difference is that all of the information is coming from the crowd. All you do is turn on your phone, iPhone, Android, Windows Mobile, or Symbian, and just drive. It's passive. So there's a lot of conversation about implicit versus explicit in the crowdsourcing world. And this is primarily just drive. And what we're doing is we're collecting information on your speed, the direction of the roads, and we're essentially taking in the US the Tiger data, which is a display map from the Census Bureau, and turning it into a navigable map together with our users. On the traffic side, we're able to make a lot of inferences based on historic speeds. We're able to tell if you're going slower or faster than what we have in the database for a particular road, and we're able to draw traffic based on this kind of information. That is really delivered on the fly, 30-second delay. The map data is updated every single day. And so this is very different than what you used to see in terms of being able to update the base map. It launched in Israel at the beginning of 2009 and reached critical mass in only about 6 months, meaning that we have got superior map and real-time traffic information for the country on about 20% of the smartphones that exist in 220,000 drivers using the application. In the US, we just launched a few months ago, but when you put this all together again, we're talking about crowdsourcing merging with real-time data, and it's leading us as an industry from entertainment to action. We can reroute you based on what we actually see in the world. And so I call this transactional cartography. We used to map objects, then we began to map people and their migration patterns, and now we're mapping actual processes. A couple of academics have called this weather mapping for social processes in the 21st century, and that's what really excites us about this.
Thank you very much, Diane. And I'm just going to give each speaker 2 minutes to kind of state what they're doing and explain where they are in their own words with their own images. And Mindy, are we all good? Or okay. Our next speaker, you've already seen some of their data, and there are towers positioned around the hotel conference area labeled Path Intelligence. And what Path Intelligence does is they're picking up our cell phone data. So when John was showing you graphs earlier today of when people arrived and who stayed late at the party, that was coming from our next speaker, the COO of Path Intelligence, Sharon Biggar.
Thank you, Brady. So at Path Intelligence, we have a vision. And if we could just go back one slide, I would appreciate that. Thank you. Our vision is that we want to take online innovations and bring those to the real world. And one of the things that the online world does very, very well is it's very good at collecting data on the user experience. So if I think about online retailers, for example, they have a lot of information on me. They know how frequently I go to that store. They know what products I'm looking at, what products I purchase, what products I don't purchase. But my local offline retail store doesn't have that information, and it's until now been incredibly difficult to get that in the real world. And that's one of the things we're trying to change at Path Intelligence. Now, how do we do that? Well, in the online world, we have companies such as Google Analytics, and they're very good at detecting and analyzing the clicks that we make every time we log onto the internet. They aggregate that information and can present it back to a website owner. What we think of what we're doing is very analogous to what Google Analytics do, except instead of detecting clicks, we're detecting anonymous pings from cell phones. Now, this does not require an app to be downloaded onto your cell phone. What we do is install sensors into high-traffic areas, and then we passively detect anonymous signals that are broadcast in the clear by your cell phone. Now, why do we think that's important? Well, what we want to do and why we think it's important is by understanding what the crowd is doing, we understand what people are interested in right now. And I really mean right now, because what we're doing is real time. And it's as real time as it's ever going to get. And it tends to lead any other information that we get, even leads tweets. And you would have seen that this morning in some of the data we presented. What you were doing by coming into the ballroom and indicating your interest in the conference was a leading indicator on what happened with Twitter and the tweets that you were making. So what we detect is real-time behavior that's right now what people are interested in. And by understanding that, we can help businesses to improve on the basis of what people want now. We have a technology that's able to locate phones highly accurately indoors. And I'm sure you can imagine there are a multitude of applications for such technology. I don't have very long, so I'm just going to focus on one aspect of what we're doing, which is right now trying to help the offline retail industry cope with this very severe recession. We are in mall sites that have more than 8 million customers across those sites every quarter. None of the sites that we have been in have failed during this recession, and indeed many of our malls are performing better this year than last. And they've been able to do that because they're responding directly to the way that shoppers are behaving. So just in conclusion, Path Intelligence has a vision to take online innovations and bring that to the real world. We do that by installing sensors and accurately locating mobile phones indoors. And we use that crowd data to help businesses improve in the real world in real time. Thank you.
Thank you, Sharon. Now, all this data is going to require a new way of viewing it, analyzing it, and to be able to use it. And this summer, we've had a number of phones add a compass to them, which, when combined with a GPS and a video camera, allows you to overlay data on top of what you're seeing, so augmented reality. And one of the most popular applications in this area is Wikitude. So I'd like to welcome out Markus Tripp, architect at Mobilizy, of the creators of Wikitude. Please welcome out Markus.
So everything started last year when we decided we had an idea and we submitted an application to the Google Android Developer Challenge. We reached it under the, where is it? We reached it under the top 50, and can you go back with the slide, please? And it was really a small project, and we developed it further. And yeah, I think the best idea is that we show you how it works. So usually we use the mobile phone, a modern mobile phone that has a GPS and a compass and you see through the camera view, you see the background, you see the reality, and we overlay it with information that is relevant in the surface. And yeah, this is something we started to develop. And what did I want to say? This is just the beginning. What we want to do next is we would like to open it for the public, so that every small community, bigger community, can create content for augmented reality. And we do this by using the similar or the same format as Google Earth, so that everyone is able to create content. And yeah, that's our project. Thank you.
Thank you very much, Markus. And it is not just commercial entities that are taking advantage of these new technologies. Also, many schools are looking into this. I'd like to welcome out a professor from UCLA, Deborah Estrin.
Okay, let me get back to the first slide. There we go. So participatory sensing is an area that we've been working on. It sort of takes you from the aggregators that you heard from at the beginning to some of the personal applications that Markus was just telling you about. And participatory sensing is about infrastructure, tools, and the practice of really people as sensors. And it's in support of specific data campaigns. When I'm feeling snide, I sort of call it Twitter or Flickr with a purpose. So it's about allowing everyday people to not just provide data to important things, such as traffic and mall traffic and such, but also to author their own data campaigns for issues that are important to them and to their community. And as we've been hearing all afternoon, smartphones and web services really provide that phenomenally scalable make-a-case technology, and they do this both through explicitly captured information as well as automatically captured information. And let me just give you an example of both of these, because examples clearly help. So my favorite example today is an application we built with the National Park Service, and it's called what'sinvasive.com. It's live, and it's basically an application where the Park Service employees and visitors can download an app to their iPhone or their Android phone, and they can use it to tag the location of invasive plant species that are threatening the native ecosystem, particularly in interest in context of climate change and these other destabilizing factors. So you can participate in what'sinvasive.com by providing data for your favorite wilderness area on your next hike. You can also participate in it by uploading the top 10 most wanted weeds for your neighborhood wilderness area that might not yet be represented with a site. But you can also use the same system to document some spatial temporal phenomenon that's of importance to you and your community. So the general technology of participatory sensing is really a story of mobile to web, and making it very easy to create your own data campaigns as well as to contribute to other people's. And so as Diane described, and as we heard from Nokia, you can also use your smartphone, not just for tagging and geocoding and uploading images, but to automatically capture data from the other sensors on the phone, such as location and motion. But you can use that information for yourself as well as for contributing to an aggregator service, or you can just use it for yourself. So again, examples help. Bitastic is a little example that we've launched, and it's a tool for cycle commuters to create and share information about bicycle commuting. And when they do that, it's not just that, as you would in a web interface, you would go up and draw your start and stop and show the route that you take. This is automatically captured information. It's an app you start, you place it in your pouch or on your bike. The information from the GPS and accelerometer is captured, activity classified, and uploaded and displayed on a map. And there you get duration of the ride, and start and stop and such, but you also get things like how long you spent at noisy, polluted dangerous traffic intersections. By definition, because you get to see how smooth is your ride versus how much time you're spending stopped and with zero acceleration versus otherwise. So it's an example of a way in which the same technology that is contributing to Waze's maps and their very important information sources can contribute to the information that you want to create for your community. And so just to then finish, these traces are a very powerful tool for both personal and community behavior change. And sort of like that Prius dashboard that we all refer to as a model for providing real-time feedback to create behavior change, to be able to see your measured behavior. And so we can use our location traces, like the ones that the cycle commuters are using. We can use our own location traces to understand the implications of where we spend our time and what we spend our time doing. So what is the aggregate air pollution I'm exposed to on days when I commute during heavy traffic hour versus when I commute at off hours? Or thinking about personal health applications, using these same kinds of traces to look for feedback when I'm trying to do some kind of drug titration or other kind of care plan adaptation. So these personal applications built off of our personal traces are a form of participatory sensing. We're participating as sensors in the capture of the data, and we're participating as users of that sensing data. And this is really a common framework that's going to support everything from the invasive plant species to your personal health management. And one of the nice things about a lot of these applications is that they scale down, not only up. So you don't need to have high market share or high penetration to gain the benefit of these applications. You just have to have value to the individual who's collecting their data and using it to understand something about themselves or about their environment. That's it.
So what types of data were now made available? Things that had never been able to be captured before by our mobile phones, by our smartphones. And first, I'd just like to say we're going to be, we're not going to take a position on phones here. No iPhones or Androids. We're going to call them all smartphones to not offend anyone.
Well, I mean, related to the geospace, we had this unit called lat long that did not have things like acceleration, speed, direction, these kinds of things that are now becoming ubiquitous. So, I mean, that opens up a tremendous amount of possibility just with that. And I would say that the other thing is being able to go from specific nodes or humans as sensors and being able to aggregate the information up so that we can see full processes and full systems wasn't really available with all of the real-time analysis and visualization that we're seeing today.
And from our perspective, having access to data 365 days a year makes a huge difference. So one of the things you get from being installed and permanently watching what's going on is access to events that only happen every so often. So emergency events are a good example. So in one of the sites that we were in, there was unfortunately a fire. But from that, no one was hurt, luckily, but we now know how people escape from that building in a real-life emergency situation. And that information is being fed back to both the emergency services and the architects and engineers to help design buildings that react to the way that people really react in an emergency situation.
I think that's a great example, and it plays out, because you were there 365 days a year, it plays out in the same context because you're with somebody 24 hours a day. So in terms of capturing those subtle events, those unusual events, because of that always on, always carried context, it's not just that the location and accelerometer and video and image and audio are available to us. It's also what we're able to infer from it. And those analyses we're able to do. 24-hour coverage on those basic media, but then all the sorts of analyses we can do.
Yeah, for instance, with our application, it's quite important because we have a small display. We cannot display all the information that is available around you, so we have to filter it. So we have to show the most relevant information for the people, and this is quite difficult. So we try to use the sensors to really filter the relevant information for the user. And for instance, if in my hometown, I'm not interested in seeing information about cheap hotels around me because I'm living there. So this is something we try to figure out and to filter out.
Now, some applications pick up data implicitly. It just tracks you as you're moving along, like yours, Sharon, with Path Intelligence. But others, like some of the apps that you were talking about, Deborah, or say Trapster, where you explicitly add a speed trap. You have people who are adding data. How can you trust that data? That's what's always baffled me.
I worry about how we trust the other data as well, right? So in some sense, it's actually an excellent question. I think it's important in all of these things. But, and so for both implicit and explicit data, giving people visibility back into the data they've contributed, both through automated capture as well as through explicit. And also, you do have eyes in the process, right? It's humans as sensors, but there are still human in the loop in terms of causing alerts, acting on the data, and such. So I don't think of these systems as entirely automated, from people as sensors to some automated response. We found in all of our campaigns that there's somebody there sort of watching. And we can put in semi-automated tools that notice the difference between harding grass and star thistle because they sort of look similar, and you can do image recognition. You can start to introduce back-end tools to try to find those things. But a huge part of it is visibility. Legible feedback to people, whether it's the operator or the individual, on what data is actually being captured.
And I would also say that while we're talking mostly about mobile devices here, a lot of the things we learn from explicit kinds of participation we take from what we learned with Web 2, right? From the web, and how people participate in communities. And so people will come to the web, and if you've driven on a specific road, you're able to update that road on the web. But the thing that's interesting, I mean, we take from there's a different weighting based on the number of people who will report something. There's a different weighting based on the contribution somebody has made back to the community. These are things that probably everyone in this room is familiar with, and they apply when we're talking about sensors and mobile as well.
And what type of critical mass of people or phones do you need in an area to start deriving value?
I think it depends on the application, and it depends on the business model. For us, we have Israel, which was a little incubator test bed for us, and so that tells us that for traffic and navigation, we're shooting for about 0.5% in a metro of the population to consider that to be critical mass. But I mean, it would be different for everybody's application that's here, and these are all hypotheses.
I think Deanne's absolutely right. It really depends on what application you're trying to achieve and what question you're trying to answer as to how many people you need in your data set. I mean, for us, we're comparing to what, I'm going to talk about retail explicitly here, what retailers had before we came along, which really was just being able to go out and talk to people and ask them how their experience was. Those were surveys that may have happened twice a year. They may have asked 1,000 people. We get 1,000 people in the first hour in a shopping center. So it's just really depends on what question you're trying to answer.
But it's a really important question for constructing applications, because it's great if you can go out with an application that has this sort of scale down property, that you don't have actually any critical mass. You're starting to provide value. And as you get more, you get the aggregate value. I mean, think about search. Search didn't start out by having the value of noticing what we search for. It just provided a value that started getting people searching. And then the huge market of seeing what we search for grew out of it. So if we can build our apps and our markets that grow up that way naturally, we'll see this stuff happening faster.
Yeah. If anybody has any questions, feel free to just go up to the mics. How do you plan on, I know this may not be your concern, Deborah, but how do you plan on making money from your apps and your data?
So we're very lucky. We have a business model that's built into what we do, in the sense that...
Someone called that planning.
Yeah. The malls are paying us to be there and providing information. Malls, amusement parks, anywhere where there's crowds wants to know how people are behaving in those areas. So they'll pay us to come and install. If we're thinking about the sensing industry, the slightly difficult thing in terms of a business model is you need to get the sensors out there somehow. So there needs to be a business model that can afford to get the sensors out into the real world. And so we've created our business model to have a pool for those sensors. So the sites that we go into really want to understand how people are behaving now, and so the demand to have the sensors put in.
And for us, for us, I would say there are a couple of things. The navigable data market is a $4 billion market that's typically been dominated by Navtech and TeleAtlas. And they employ, as the woman from Nokia mentioned as well, pretty expensive, historically, methods for gathering that information. And so when you look at the base maps and how much that has been worth all the way up to the real-time traffic, and then you look at the fact that crowdsourcing enables us to allow people to have a free application, then we're able to sell that data at a very low cost. Now, there are other companies, a little company called Google, trying to disrupt the same market, and about a week and a half ago, they released their own map in the US, and so that's shaking things up a bit for us, but luckily it's also a time when we've got location-based ad platforms finally coming into their own. And this is something that, you know, on the web, we've been waiting for this to come along, and the right set of circumstances hasn't existed. Now we know so much about the user and where they are that there's a lot more value to advertisers. So we've got both the data and the advertising.
Yeah, I think that $4 billion market is going to be shrinking soon.
I think it's already shrunk overnight. But that means that there's still room for a player like us who has the low-cost ability to come in and try to help other people innovate.
Markus?
Yeah, for us, for instance, it's a very new business we are entering, and
but you're already profitable, or at least revenue generating.
Yeah, we generate revenue, so we're privately financed, so we make enough revenue for our cash flow. But our main goal is to get reach and get as many content as possible into our system. And this is our main goal. And then there are several ways to create a business out of it. And one of the possibilities is using the sensors, using location-based advertising. This is still in the beginning, but we think this is growing in the next couple of years.
Now, is Twitter the ultimate human sensor?
It's an interesting data set,
yeah,
for sure.
So there's a really cool site called Your Flowing Data that Nathan Yao, who runs a flowing data set, and you set up a Twitter. We set up for Your Flowing Data to watch your Twitters. You can define your own little bio measures, whether you're trying to drink less Diet Coke or yell less often. You define your own little things to measure, and you Twitter to your own account. So many ways to use Twitter.
I think it's another indicator of interest. So people indicate their interest in something by either turning up to it, or how long they spend doing it, or by how many tweets they make about it. I just think it's just another piece of data to add into the equation.
All right. Well, we're out of time. Thank you very much.